I'm going to show you how to calculate an empirical formula. Before I do that, I'm going to review the calculation for percent composition by mass of a compound. The reason I'm doing that is because to calculate the empirical formula, it's going to be the opposite of calculating that percent composition by mass. So let's review. To calculate percent composition, I start with a formula. Let's have an example of C2H6. From there, I can get the moles of each of those elements. In this case, I would have 2 moles of carbon for every 6 moles of hydrogen. Then I want to get grams from moles. So I'll do a conversion using conversion factors. So 1 mole of carbon is 12.01 grams of carbon. 1 mole of hydrogen is 1.01 grams of hydrogen. So that would be 24.02 grams of carbon, and this would be 6.06 grams of hydrogen. From the grams, I'll get the percentage. Percentages is the part divided by the whole, and I multiply it by 100 to go from the decimal to the percent. So I need the whole. So I need to add up the grams of carbon and the grams of hydrogen, and I'll get 30.08 grams total. If I take 24.02 and divide it by 30.08, that gives me 79.9% carbon. If I take 6.06 grams and divide it by 30.08 grams, I get 20.1% hydrogen. And this, of course, adds up to 100%. But I want to tell you how to calculate an empirical formula. The idea of an empirical formula is that we can get a formula from an experiment. What a chemist can do is they can take a substance and they can analyze it, and they can figure out percentages of elements in a substance. So like I said in the beginning, if we have the percentages, we're going to work backwards from percent composition to the formula. So if we have the percent, we're then going to calculate the grams. From the grams, we can convert to the moles, and from the moles, we'll get a formula. Let's have an example problem for an empirical formula. Problem says an oxide of chromium is found to have the following composition: 68.4% chromium and 31.6% oxygen. Determine the empirical formula. So we'll write down these facts. 68.4% chromium, 31.6% oxygen. And as I said, we're going to work backwards. We're going to have the percent. From that, we'll get grams. From that, we'll get moles. That will lead us to a formula. So what we do if we start with percentage to get grams, what we'll do is that we'll say, okay, if we had 100 grams of the substance, that would give us 68.4 grams of chromium and 31.6 grams of oxygen. So real easy. If they give us percentages, just call that percentage grams. All right, from there, we're going to convert to moles. So we'll multiply using our conversion factor. So 1 mole of chromium equals 52 grams of chromium. And 1 mole of oxygen is going to equal 16.00 grams of oxygen. So essentially we're dividing 68.4 divided by 52 and 31.6 divided by 16. So here I get 1.32 moles, and here I get 1.98 moles. And of course this is chromium and this is oxygen. So from the moles, I can get the formula. Am I allowed to put this down as a formula? No. I need whole numbers. We can't have these decimals. So what we're going to do is we're going to tweak this a little bit so we can get whole numbers. The way you do that is you take the smaller number and then you divide by that. Divide all the numbers by that smallest number. So if we divide each of these by 1.32, of course we get 1 here, and we'll get 1.5 here. All right, so does that mean that this is a valid formula? No. I need whole numbers. So I still need to fix this. So if I look at it, I figure that if I multiply each of these by 2, I can get whole number ratios. And then I can have a formula of Cr2O3. And that is a valid empirical formula.